Welcome to Spring LIB.
So taking a look at the last podcast here for the electrochemistry series, where we're essentially just looking at the movement of electrons, the voltages associated with them within the system, where we can make the assumption first where we have B2 plus, add 2 electrons, generate B, 0.00 voltage, made that assumption. So from that data, when B over B2 plus and E over E2 plus are together in a cell, we have E0 is 0.81 volts, meaning that E2 plus add 2 electrons. E2 plus add 2 electrons generates E, must equal positive or negative 0.81 volts, depending on being in a reduction or an oxidation reaction. So from largest to smallest, we can arrange some values here. D2 plus 2 electrons to generate D, 0.19. B2 plus add 2 electrons to generate B, 0.00 volts. A2 plus add 2 electrons to generate A is negative 0.53 volts. Next we have E2 plus add 2 electrons to generate E is negative 0.81. Lastly, we have C2 plus add 2 electrons to generate C is negative 0.94 volts. So because A2 plus add 2 electrons to generate A is in the middle, we assume this is 0, and then we can rewrite out our values as 0.72 volts, 0.53 volts, 0.00 volts, negative 0.28 volts, negative 0.41 volts, where we've just added 0.53 volts to all of our values here. So in the previous case, we assumed that the potential was negative 0.81 volts. We can also assume it's positive 0.81 volts. And if we do so, we get the following table, where we have C2 plus add 2 electrons to get C, 0.41 volts, E2 plus add 2 electrons to generate E, 0.28 volts, A2 plus add 2 electrons to generate A is 0.00 volts still, B2 plus add 2 electrons to generate B is negative 0.53 volts, and lastly we've got D2 plus add 2 electrons to generate D is negative 0.72 volts. So one of the ways to identify the correct table is to add the metal C to a solution of D2 plus and metal D to a solution of C2 plus. So if D comes out of solution, then the first table is correct, and if C comes out of solution, then the second table will be correct.